Hi, this is Group Friday 44P4, and our problem is to create a mechanism that allows the client to play board games while minimizing strain and lateral movement. Here is our XY grappler.
Hi, I'm Ghena, and today I'm going to talk a bit about why our product is innovative. So, the functionality and optimization of our product provides for a unique solution for people like James who would simply like to indulge in quality time with their loved ones without the threat of pain or discomfort. Our product is innovative because it is highly adaptable to several different tabletop games and it is able to pick up and drop off a multitude of different pieces thanks to the grip on the claw, and it is also adaptable thanks to the size of the mechanism. James has stated his desire to be able to play games with his kids comfortably, and our design provides that with a relatively low cost, with little to no bearing on other participants of the game.
Hi, my name is Om. I was part of the mechanical side of the project. I helped design and build the XY gantry. In our design, we used polycarbonate instead of acrylic because it is substantially more stable and durable and is less prone to fractures. Moreover, we chose to use steel rods for the XY gantry to move on because steel rods are rigid and have a smooth surface for the blocks to slide on. Furthermore, we used dry nylon sleeve bearings for the metal rods to reduce friction and improve the stability of the XY gantry. Finally, we decided to use a Core XY design due to the fact that it uses the least amount of motors and is a simple yet effective design.
Hi, my name is UC and I worked on the programming and hardware aspects of this product. We controlled the stepper and servo motors on the gantry using a combination of a Raspberry Pi and two Arduinos. We utilized the Python modded library to convert Python into operable Arduino code and the Pygame module to interface a gamepad controller as a joystick and operate the XYZ axes and claw. We chose to use the Raspberry Pi and Arduino combination as we already had the devices and wanted to repurpose them for a more innovative project.
Hi, I'm Hazel and I worked on the claw for this project. In the research done for the ideal claw design for our mechanism, it was decided that a three-fingered claw would be the most fitting solution. A four-fingered claw was found to be more bulky and a two-fingered claw would provide less grip and stability. In order to be more cost effective, instead of using a linear motor, which was the initial idea, the less expensive servo motor was utilized. The rotational motion of a servo motor was translated into linear motion by using a rack and pinion mechanism. This allowed the claw to protract and retract by moving it up and down.
Hi, my name is Gordon, and I worked on the controller aspect of this project. So, for some background, as a group, we knew early on that using a controller would be the ideal interface for the XY gantry, as it's a straightforward process to configure it with code and other components of the project. Unfortunately, the controller's joysticks are not exactly ergonomic and could cause pain for the client after prolonged use. Thus, to fix this, we used an extension mechanism for the controller joystick and designed an ergonomic round-shaped handle that minimizes strain in the fingers. Although the project costs upwards of $315, it is a fraction of the price compared to existing design alternatives such as the Q-arm. The general list of materials include two stepper motors, two servo motors, wood, polycarbonate, belts, pulleys, rods, and 3D printed parts. Since we incorporated a variety of 3D printed parts, we were able to greatly reduce costs as they are much cheaper to produce compared to other materials. We also use a variety of hardware, including screws, nuts, and a drill. The team sought out the least expensive yet effective parts that could possibly be used.